Hi, if you are watching this, then you missed the beginning of class, and this is a reteaching or an enhancement evolving of day two. One of the goals of this is to understand new definitions for trig functions using x, comma, or x, y, and r, and how those work. The lesson will conclude with a pair deck review. So on the right-hand side, we have our four reference triangles that make our bow tie shape. We've got our theta in the middle. Remember, these bow ties are always drawn by capping off the triangles by drawing them down to the x-axis. On the left, we have our sine, which is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent, SOHCAHTOA. But there's a better way that we're going to start thinking about all of these, and we're going to change our definitions of SOHCAHTOA up and evolve a little bit to help us. So let me show you the way. And looking here on the right-hand side, if we look at a triangle in quadrant 1, we discussed that there was a coordinate point up here, and that coordinate point was x comma y. To get to that coordinate point, you would walk along this distance, which is the adjacent in this case, and then you would go up the opposite. Well, because we're dealing with a coordinate grid, really what I want you to start thinking about is adjacent is the x value and the opposite is the y value. And the hypotenuse is something called r, which I'll talk about a little bit in a little bit. But that transforms my Pythagorean theorem into x squared plus y squared equals r squared. And this might provide a lot more meaning with what's going on because we're dealing with a coordinate grid and it's easier for us to understand x and y. And so what that does is that transforms my sine definition instead of opposite over hypotenuse. It translates into y and r. Y is the same thing as the opposite. The r is the same thing as the hypotenuse. So this definition for sine becomes really important moving forward. Cosine would be x over r because the adjacent is the x side and the hypotenuse is the r. And tangent is y divided by x. This one's a little tricky to remember. It's very easy to flip flop. So, I mean, if you're still using O over A for that one, I can't fault you for that. I find myself doing it as well. But this isn't true just for quadrant 1 because these opposite hypotenuses and adjacents work for all the quadrants. So, what is R? R stands for a radius because what we talked about rotations the other day, and if you think about a rotation as a continuous circle, my circle's busted, um, then the hypotenuse becomes the radius. The radius is from the center to the edge of a circle. And that's how we got x squared plus y squared equals r squared, which is actually the formula for a circle if you go and study circles at some point in time. Big important note, r is always positive. Always, always, always. So what does that allow us to do? That allows us to clean up our opposite, adjacent, and hypotenuse definitions. And provide meaning to the quadrants as well. Because we know in quadrant number 1 that adjacent is x, it's also positive. We know the opposite is y, which is also positive, and the hypotenuse is r, which is always positive. But then when I go this way on the coordinate grid, you're still moving x when you're going from the center to the outside, but now it's negative. When you're going up, that's positive y, But when you're going down, that's negative y. And these are still the radii. And this opposite is negative y. So those coordinate that we talked about in day 2, where this is first quadrant's positive, positive, x and y are both positive. In quadrant 2, x is negative and y is positive because of the rules of the coordinate system. And in quadrant 3, we have negative x and negative y. And in quadrant 4, we have positive x and negative y. So just something to think about. And so I really want to encourage you to revolutionize your sine, cosine, tangent to use x, y, and r. You've got them on a study guide sheet. They should be written down in your notebook page. You should be using them enough. You should be memorizing them. So let's do one more problem from Friday, but using x, y, and r. So I've got the point 2 comma negative 5, and I want to know what quadrant that's in. So I know that that is x, y. So since y is positive, negative, that's down here in quadrant 4. And I'll build my triangle. My triangle is being funky. There we go. But since the x is 2, we know that that leg of the triangle is 2, and the y is negative 5. We know that leg. My Pythagorean theorem, my radius or my hypotenuse can be gotten by using the Pythagorean theorem, which is x squared plus y squared equals r squared. So x is 2, y is negative 5. Make sure you use parentheses. Cannot stress that enough. And that's 4 plus 25. Don't be having a negative 25 here. 4 and 25 make 29, which then you square root. The radius is root 29, not 27, 29. And you can just put that over here. And now, since we want to answer what sine is the y side divided by the radius in that new definition. So that means I just have to look at the y, which is right here, and the radius, which is root 29, and divide those. So I have negative 5 over root 29, which I must rationalize. So I get a final answer of negative 5 root 29 over 29. And there we go. So there's a quick recap of what we did in day 2 using x, y, and r definitions to just further enhance our learning. Thanks for watching.